Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Today we are going to start with the new subtopic, which is 4.2 molecular shape and polarity. So in this video we are going to focus on molecular shape or molecular geometry and VSEPR theory. So this is the learning outcomes. So VSEPR theory emphasize that each group of valence electrons around the central atom is located as far away as possible from the others in order to minimize the repulsion. Okay, so based on VSEPR theory, we know that we have two different electron pairs. The first one is lone pair. Okay, lone pair electron, and the second one is bonding pair. Okay, bonding pair is electron that is shared between two atoms, the central atom and the terminal atom, and the lone pair is a non-bonding electron. Okay, so these two electron pairs have different strength of repulsion. Okay, it can repel between lone pair and lone pair, also lone pair bonding pair, and bonding pair bonding pair. So the strength of repulsion, the strongest repulsion is between lone pair and lone pair. Okay, the second one is between the lone pair and bonding pair, and the third one, the weakest repulsion, is between bonding pair. Okay, so since lone pair has a greater repulsion, so it will change the shape of molecular geometry from the basic molecular geometry. Right, so we are going to apply VSEPR theory in order to determine the molecular shape. But before that, let's discuss about the basic molecular geometry. We have 5 basic molecular geometry. The first one is linear. So for basic molecular geometry, what is important? You need to memorize the name of molecular geometry. You need to know the shape. You need to know how to draw the shape of molecular geometry and the number of bonding pairs or electron pairs around the central atom. So for linear, we have 2 electron pairs around the central atom, and the bond angle is 180 degrees. Okay, the angle between these two bonds, okay, 180 degrees. The second one is trigonal planar. Trigonal planar is the basic molecular geometry that has 3 electron pairs around the central atom. Okay, the basic molecular geometry also called as electron pair arrangement. Electron pair arrangement. Okay, because the electron pair arrangement is based on the basic molecular geometry. How many electron do we have around the central atom? That is the electron pair arrangement. And how we determine the electron pair arrangement, it based on the 5 basic molecular geometry. So trigonal planar, we have 3 electron pairs here. Okay, so the bond angle between the bonds is 120 degrees. It is actually 360 divided by 3, because trigonal planar is triangle that is on the same plane. Okay, next one we have tetrahedral. So tetrahedral is the basic molecular geometry when we have 4 electron pairs around the central atom. Okay, 1, 2, 3, 4, and the bond angle is 109.5 degrees. Okay, same for all the bond angle. Okay, this is trigonal bipyramidal. Okay, trigonal bipyramidal is the basic molecular geometry when we have 5 electron pairs around the center atom. Okay, 1, 2, 3, 4, 5. Okay, trigonal bipyramidal. Sebenarnya bentuk ni adalah bentuk apa? Segitiga piramid yang base-nya adalah segitiga. So base-nya ni sebenarnya adalah trigonal planar lah. Bentuk trigonal planar tadi jadi dia punya base, tapak dia, dan ada piramid atas dan bawah. Okay, so we have two bond angles here. Okay, dekat trigonal planar tadi sama 120 degrees. Okay, dan untuk yang tegak ni 90 degrees. Okay, last one for basic molecular geometry, we have octahedral when we have 6 electron pairs around the center atom. Okay, so ini pun sebenarnya masih lagi piramid, tapi kita punya base tapaknya adalah segi empat ya. Okay, square. Actually this is square with 2 pyramid. Okay, square bipyramidal. Okay, nama dia kita bagi octahedral. Okay, kenapa octa? Octa ni 8 ya. So kenapa octa? Sebab dia ada 8 sisi. Okay, kita kira dia dapat 8 sisi. So the bond angle is 90 degree. Okay. Okay, so that is 5 basic molecular geometry. Just now, a linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. So these 5 basic molecular geometry, or we call as electron pair arrangement, when there is at least one lone pair on the central atom, the molecular geometry will change to a new molecular shape. Okay, so these are some of the molecular shape with lone pairs. The first one is band. Okay, band, for band or V shape, actually we have 3 electron pairs here, 1, 2, 3. So when we have 3 electron pairs, we can identify the electron pair arrangement is actually trigonal planar. Okay, based on the number of electron pairs. 3 electron pairs. Okay, so since one of the electron pair is a lone pair, so based on VSEPR theory just now, we know that lone pair repulsion towards bonding pair is greater compared to the repulsion between bonding pair. So the molecular shape become band. Okay, so the bond angle, bond angle for band should be less than 120 degrees, because the bond angle for trigonal planar is 120. So since we have lone pair here and the repulsion is stronger, so it will repel the bond, these two bond, and reduce the bond angle. And then trigonal pyramidal. Okay, trigonal pyramidal is when we have 3 bonding pairs and 1 lone pair. That means we have 4 electron pairs. So 4 electron pairs means the electron pair arrangement is tetrahedral. Okay, since we have 4 electron pairs. Okay, so since one of the electron pair is lone pair, and the repulsion between lone pair bonding pair makes the molecular shape change to trigonal pyramidal, and the bond angle is less than 109.5 degree. Okay, why less? Because we have 1 lone pair here, and 109.5 degree is the bond angle for tetrahedral, the basic shape just now. Okay, this is for band, but this is band that form when we have two lone pairs and two bonding pairs. Okay, for electron just now we have tetrahedral. So this repulsion, here we have three different repulsion. The repulsion between lone pair bonding pair, and bonding pair. Since we have two lone pair here, so the bond angle should be smaller than 109.5 degree. Okay, but if we focus on example H2O, okay, the bond angle for H2O is 104.5 degrees. Okay, next. Okay, this is seesaw or distorted tetrahedral. The electron pair arrangement here is trigonal bipyramidal. Can you see the trigonal planar and the pyramid here? Okay, so this is electron pair arrangements since we have 5 electron pairs. Okay, but one of the electron pair is lone pair. So based on VSEPR, the repulsion, the molecular geometry becomes seesaw, and the bond angle is decreased. Okay, the bond angle become less than 120 degrees and less than 90 degrees. Okay. Okay, this is T-shape, also from trigonal bipyramidal, since we have 5 electron pairs. Okay, 2 are lone pairs, so we have repulsion between lone pairs, bonding pairs, and bonding pair. So the shape become T-shape, and the bond angle is 90 degrees. Okay, this is linear when we have 3 lone pairs and 2 bonding pairs. So the bond angle, the angle between bond here is 180 degrees. Okay, this is square pyramidal. Square pyramidal originally from octahedral because we have 6 electron pairs around the central atom. So the electron pair arrangement is octahedral since we have 6 electron pairs. Okay, so one of the electron pair is lone pair, so the repulsion makes the bond angle become smaller and the molecular shape become square pyramidal. Okay, and the bond angle here should be less than 90 degree. Okay, the last one is square planar. Okay, this is square planar. Okay, we have square on the same plane. Okay, we have 2 lone pairs and 4 bonding pairs. So the repulsion between lone pair and lone pair, bonding pair, make the molecular shape become square planar, and the bond angle is 90 degree. Okay, so as a conclusion, the repulsion, the strength or the different strength between electron pairs change the molecular shape and the bond angle of molecule. Okay, this is the summary of all the molecular geometry and molecular shape with lone pairs. Okay, so these are the steps you need to do in order to predict the molecular shape. The first one, you need to draw the correct Lewis structure. Okay, this is the first step. So the first step is very important. You need to have the correct Lewis structure. If your Lewis structure is wrong, then your molecular shape, your polarity, your overlapping will be wrong. Okay, so the first step is very important. You need to know how to draw the correct Lewis structure. So if you have problems in drawing the Lewis structure, please study on the Lewis structure first before you continue with this molecular geometry. Okay, when we have the Lewis structure, we need to determine the number of electron pairs. Okay, this one is used to determine the electron pair arrangement based on the basic molecular geometry that we have discussed just now. Basic molecular geometry. Okay, how many basic molecular geometry do we have? We have 5 basic molecular geometry. These 5 basic molecular geometry will determine the electron pair arrangement based on how many electron pair that we have around the central atom. And then we apply VSEPR theory. Okay, what we need to know about VSEPR theory? The repulsion between lone pair is greater than lone pair bonding pair and greater than bonding pair. Okay, so identify the electron pair arrangement. This one based on the number of electron pair just now. State the class of molecule. This we are going to use symbol A for the central atom, B for the terminal atom, and E for the lone pairs. And last one, draw the shape and state the bond angle based on the VSEPR theory. Okay, let's look at the first example. Okay, this is CCl4. Okay, CCl4, we start with the Lewis structure, the correct Lewis structure. We have the correct Lewis structure here. Okay, and the second step, determine the number of electron pairs. So we have how many electron pairs around the central atom? We have 1, 2, 3, and 4. Okay, electron pairs are all lone pairs and bonding pairs. Okay, so 4 electron pairs and all are bonding pairs electron. Okay, the class of molecule is AB4. Why? Because we have 1 central atom and 4 terminal atoms. The electron pair arrangement is tetrahedral since we have 4 electron pairs around the central atom just now. And according to VSEPR theory, okay, we need to state this in your answer in order to predict the molecular geometry. Okay, repulsion of bonding pair electrons are equal. Okay, therefore the shape is tetrahedral and the bond angle is 109.5 degrees. Okay, this one is simple because it does not involve a lone pair on the central atom. Okay, let's look at the second example. Okay, SEF4. Okay, for SEF4, first count the total number of valence electron. Then we have the correct Lewis structure here. Okay, so you need to calculate, you need to count the correct number of electron pairs here. We have 1, 2, 3, 4, and 5 electron pairs around the central atom. So 5 electron pairs means the electron pair arrangement is trigonal bipyramidal. Yes. So the 5 electron pairs are 4 bonding pair, 1, 2, 3, 4 bonding pairs, and 1 lone pair here. Okay. So since we have 1 lone pair here, based on VSEPR theory, the repulsion between bonding pair lone pair is greater than bonding pair. So the molecular geometry is seesaw, and the bond angle become less than 120 and less than 190. Okay, the class of molecule or the formula is AB4E. Okay, 4 terminal atoms, 1 lone pair, and 1 central atom. Okay, this is the last example, XEF4. XEF4, here we have 1, 2, 3, 4, 5, 6. We have 6 electron pairs around the central atom. It makes the electron pair arrangement octahedral. Then the 6 electron pairs just now are 4 bonding pair electrons and 2 lone pair electron. So this is the class of molecule AB4E2. And based on the VSEPR theory, since we have 2 lone pair here, so there is a repulsion between lone pair, which is greater than repulsion between lone pair bonding pair and bonding pair. Therefore, the molecular geometry is square planar and the bond angle become 90 degrees. Okay, so I hope you understand, and please try to answer the tutorial question related to molecular geometry. You need to practice and try to understand how to predict the molecular geometry. Okay, so remember, you need to memorize all the basic molecular geometry, all the molecular geometry with lone pairs, all the bond angles, and you need to know how to draw, okay, how to draw the molecular geometry. Okay, that's all from me. Thank you.